Hello everyone, in this video we are going to focus on the circular motion or angular motion. And we are going to solve some examples or some questions of circular motion. Let's start with the first question. A mass of 150 grams is attached to a string of length 1.2 meter. The string is used to whirl the mass in a horizontal circle at 2 revolutions per second. A. Calculate the centripetal acceleration of the mass. A mass of 150 grams. Say this is the velocity V, and velocity is tangential to the circle. If this is the center, and this is the centripetal force F, also centripetal acceleration A. Both are vectors, and also velocity is a vector. It's given that the mass of the particle is equal to 150 grams, which is equal to 0.15 kilograms. And the radius of the circle is 1.2 meters. That means R is equal to 1.2 meters. And also it says 2 revolutions per second means the frequency of the revolution is 2. And that means the period of the motion is 1 over 2, which is equal to 1 over F, the frequency of the revolution or the motion. Now, it says calculate the centripetal acceleration of the mass. Using the formulas of circular motions, we know that centripetal acceleration is equal to angular speed square times radius of the motion. Then it's equal to let's first calculate the angular speed. You know that angular speed is equal to, or angular velocity is equal to 2 pi f. Then angular velocity is equal to 2 pi times 2, which is equal to 4 pi radian per second. Then centripetal acceleration is equal to 4 pi square times radius is 1.2 meters. 1.2 meters, which is equal to 189 meters per second square. This is the answer of choice A. Let me change the color. Choice B. Calculate the centripetal force acting on the mass. You know that centripetal force is equal to MA, which is equal to mass is 0.15 kilograms. 0.15 15 kilograms times acceleration is 189. And this is equal to 28.4 newtons. This is the answer of choice B. Again, let me change the color. Choice C. The string has a braking force of 56 newtons. Calculate the maximum angular velocity of the mass. This is the string. Calculate the maximum angular velocity of the mass. We know that the centripetal force is equal to also m times angular velocity square times radius, which implies that angular velocity is equal to square root f over mr. Let's continue here. Then it's equal to square root. F is given as 56 newtons. 56. Mass is 0.15. Radius is 1.2 meters. Then this is equal to 17.6 radian per second. That's the answer, and that's the answer, and that's the answer. I hope it's clear. Now let's go to the next question. This is the second question. A mass of 0.5 kilogram is attached to a string of length 0.45 meter and rotated in a horizontal circle. The mass has a linear speed of 7.6 meter per second. Calculate the tension in the string. Let's first draw the diagram of the motion. In a horizontal circle, it says, this is string. Let's assume that it rotates in this direction. This velocity, and radius is 0.45 meters, and it's given that the mass of the particle is 0.5 kilogram and radius is equal to 0.45 meters, and the linear speed or the tangential speed is equal to 7.6 meters per second. It says calculate the tension in the string. Tension in the string. This is T. The tension in the string is equal to centripetal force, which is equal to mass times linear velocity square divided by radius, which is equal to 0.5 kilograms times it is 7.6 meters per second. 7.6 square divided by r, 0.45. Then F, or tension, is equal to 64.2 newtons. I hope it's clear. That's the answer. Again, we have used the circular motion formula. Now let's go to the next question. Okay, this is the third question. A 3.0 kilogram mass attached to a string of length 0.75 meter rotates in a vertical circle with a steady speed of 8.0 meter per second. A. Calculate the tension in the string when the mass is at the top of the circle. And B, C. Let's write down the givens. Mass is equal to 3 kilograms. And the length of the string, that means the radius, is equal to 0.75 meters, and the speed is 8.0 meters per second. Velocity or speed is equal to 8 meters per second. Now let's draw the diagram of the motion. Because it says it rotates in a vertical circle. This is a vertical circle. And at this point, this is the top point. This is the minimum point, or this is the maximum point. Velocity, and this is the minimum point. And this is the radius, r, 0.75 meters. Velocity is 8 meters per second. The mass is 3 kilograms. It says calculate the tension in the string when the mass is at the top of the circle. Let me change the color. At the top, and this is mg. At the top point, F minus mg is equal to tension, or it's equal to m velocity square divided by r minus mg. This is F. It says calculate the tension. Then tension is equal to mass is 3, velocity is 8 square, radius is 0.75 75 minus 3 times 10. Then tension at the maximum point or at the top is equal to 226 Newton. That's the answer for choice A. Now let's consider the choice B. Calculate the tension in the string when the mass is at the bottom of the circle. At the bottom, again, there is an mg in this direction and tension in this direction. Then tension is equal to F plus centripetal force plus mg, isn't it? Then it's equal to, again, m v square over r plus mg, and it's equal to 3 times h squared divided by 0.75 plus 3 times 10, which is equal to 286 Newton. As you can see, it's greater than 226 Newton. The tension at the bottom is greater than the tension at the top. And let's consider the choice C. Calculate the minimum speed required for the mass to move in this vertical circle. For choice C, we have to consider the conservation of energy. The kinetic energy at the bottom of the circle must be equal to the potential energy at the top of the circle. So 1 over 2 mv square must be equal to mgh. We can cancel this m with this one. Then which implies that v square is equal to 2gh, which implies that v is equal to square root and 2gh. Let me erase this part. It's equal to here 226 newtons. Then velocity is equal to square root 2 times 10 times h is the diameter of the circle. It is 1.5 meters. And this is equal to 5.5 meters per second. That's the answer. I hope it's clear. Please like and subscribe to my channel. Thank you very much. Please like and subscribe to my channel. Thank you.